Okay, I'm going to talk about art lines. So first of all, the art line. The art line that we use, it looks like this. Can't mention any brands, but this is the one we use. In particular, I'll show you, we have the specialty of a built-in syringe. Now, this particular art line is designed so that the ports for sampling are one-way system. We can take blood out of these, but we can't inject into them. So I'm simulating here that the art line is connected to an artery, and later on when we do the blood gases, we can then draw back some fake red-looking fluid, fake blood. Now, also noticeable that I've put art line labels next to the two ports that we have. There's a second port with another label, and also on the side of the spike here, yeah, there's my spike, I put on a third label. So the art line can sort of be divided into three different parts if you want, but I think that makes it easy. So here, and I follow that through, is my line that's connected to my bag of fluid eventually. Let me open this up. And it comes here into this unit with the sensor, and there's also this blue thingy, lever, which you use to prime or flush the line. And once you've done it, the priming of the line and this little hub here, you put a hub on it. Also make sure that the connection is secure here and the connection is secure there. Just so you have a look at these switches. So this long bit means closed. So this port here, which is a port we can open to the air, is at the moment shut. And then we'll go through this inline syringe. This way it is open to the sensor and also to my fluid bag and the spike there. And also characteristically, this line that comes from the fluid into the sensor is very soft. The line that feeds back from the arteries, and most commonly the radial artery, is very rigid. This is an easy practical tip that if you would have to zero the line, you would close to the patients like so, and you would close to this rigid bit of line if you can't follow it all the way back underneath the drape to the patient's arterial access. Okay, so I've got my port closed there, second port closed, and then I've got arterial access. So for the priming of the line, I'm using normal saline because saline will be eventually pressurized going into my artery, and there will be a very small contamination of the arterial blood with normal saline. So you can imagine if you use Hartmann's or Plasmolite as a crystalloid, the contamination will be worse than just using normal saline. Okay, and priming is done under gravity. So my pressure bag that I need is completely undone, and the priming happens when all ports are securely connected and they're open by just simply pulling on this lever, maintaining, and all the way till the line is primed. And then of course when the anaesthetist has the arterial cannula in place, you can then connect your line to the patient. But if we haven't pressurized the bag before connecting to the patient, blood will start leaking back, flushing back into your line. So therefore we will inflate this bag to a pressure of about 300 within the mid of the green zone. So my lever here, I need to be closed off to the air, and I'm using my little bulb to increase my pressure. So if you get close, you see the line on the outer casing is just above 300, and that's an adequate pressure to prevent reflux of blood into my line. So now I've got an art line, say that I have arterial access, art line is connected on the pressure, and the next step that I can do is the monitoring of the blood pressure. For the monitoring of blood pressures, we need some cables in this particular monitor setup. So here on the side, I can access this lead. It will have one says PA and PB sockets, and this monitor is uniquely set up to recognize art lines to go on to the PA socket, and you can see the socket looks like that, which will connect to obviously this part of the cable, whereas this end of the cable that looks like that will connect to the cable coming off the sensor of the art line. For arterial lines to give a reliable, trustworthy reading, this sensor needs to be placed kind of in the mid-axillary line at the level of the fourth intercostal space. 1 centimeter too high or 1 centimeter low can make a difference of about 5 millimeters of mercury per go. And it also needs to be calibrated to the atmospheric pressure in the room, and this process is called zeroing. So this needs to be in the right spot. Then I need to find out, this is soft, this is hard, so that's towards the patient. I'm going to close to the patient. I'm doing this one-handedly, so it's just very hard. And here I'm opening up to the air. So close to the patient, open to air. So now my next step is to connect this cable here. There we go. Now the art line box comes up. So what I'm going to do is rotate the dial so there's a blue box around it. Press on it. It says 0. I go to 0. Press 0. And now my art line is zeroed. Okay, and then to finish off, I now need to replace my cap, close off to air, have a continuous line, and if I move my art line, you'll see I get a reading because it's not a real artery. So here you go, shake, 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 and there you go, shake, shake, shake. Okay, so I'm going to demonstrate the process of taking an arterial blood gas. So you might have been familiar that to discard this contaminated blood, you take a sample where it's maybe 5 mils, discard that blood, take your second sample which you use for analysis in the ABG machine. So in here we have a built-in syringe. So what we can do is we can take blood from the virtual artery that moves past my first port all the way past my second port into the syringe. So if I draw back 6 mils or more blood in here, which I can later give back to the patient, in particular my first port will have fresh blood. So notice that I've closed a little hub that goes towards the port. The port is one way, so I can get blood out. I cannot inject into it. I've got my safety label here that I know it's an art line. Yep. So now what I need to do is to draw back blood into the syringe. So I must make sure that I'm not drawing, because there's 2 connections here, the drawback from here and not back from my fluid line. So I'm closing it, looks like so. So it's cannot draw back from the air, it cannot draw back fluid from my fluid bag. And now this port is closed as well. With this syringe, I just need to, there's a little lever there, I just need to push it towards the plunger. Yeah, and hope I do it. And now I'm going to draw back some blood. So as that happens, you can see blood is drawing back. Yeah. And now we'll start entering my syringe. This syringe has markings on it. So I've gone back 10 mils, that should be more than enough. And now I can make my port ready. So that's towards my patient. So I'm now going to close off towards my syringe. So if I take blood from here, it will come uncontaminated from my patient. It's going to look funny, but connect my blood gas syringe, take my sample. Yeah, not easy when you're one-handed. Here we go, but you get the drift. Here's my sample. So my sample I need to shake or roll. Yeah, it's a bad sample because it was one-handed. That goes to the blood gas machine, and now I need to flush all the blood back. So first thing I do is I take my syringe and now I can give that blood back. Need to open my line first. So notice that I keep also open to the port, which is important for flushing later on. Now my syringe can go back. You heard the click. It's clicking there with that extra lever. Yep. And now I want to flush my line. So because I took a sample in here, you can see the little hub there has blood in it. So I need to flush that out. So the way I do that is close to the air, open to the line, and now you can see the flushing taking place all the way back to my bag. This little hub is clean as well. Close my port. Port is closed. It's open here. I check my pressure. It's still, yeah, it can go up a little bit. So here we go. Because I flushed, I lost some. That's good. Close this back. And that's it.